Okay, forging on. Let me get the share screen going here. So joints, I mentioned as one of the components, the rigid body, the collider, and the joints. And joints allow us to kind of connect two objects um, with the, um, and we'll see a number of different types of joints. Let me show you an example of this. In particular, I'll show you the fixed joint. And the fixed joint attaches two objects to each other in a rigid fashion. It's fixed. Their orientation is fixed. One interesting feature of the joint is that they are breakable. You can specify a brake force or torque threshold. Uh, and if the forces that Unity calculates as this thing bounces around in the world, is hit by bullets or whatever, exceeds that brake force or brake torque, the joint can be broken. There is an infinity setting that technically is unbreakable. I have seen them stretch, but they don't break. So let me show you the fixed joint. Oh, I have to get into a different version of different editor here. Sorry about that. Well, the world looks pretty much the same here. So here's the fixed joint scene. Now, before I do that, let me show you this object over here, because this is I've got this cube, and it has a sphere, and the cube and the sphere both have rigid bodies, and the sphere is the child of the cube. But watch what happens when I play this. They don't stay attached to each other. That's because they're individually rigid bodies being controlled by the physics engine. If I take the rigid body out of this sphere, let me take the rigid body out of it, yeah, out of this sphere. I'll take that rigid body off. And now the cube is a rigid body, and the sphere is now, as a child of that, is now part of the rigid body. And so it looks like we can connect things together in this way, and we can. But this doesn't have the feature that uh, that it, it's breakable. And if you remember what we talked about with colliders that don't have rigid bodies, that they're not taken care of by the physics engine that well if they move. And so this might cause some confusion for the physics engine. So instead, we'll use joints. Now, joints have a connection. Here's my fixed joint. And I'm using a container here because sometimes it's easier to put things inside an object and have them as children. So my fixed joint object is just a transform that I can position in the world, and my slab H, the horizontal slab, and my slab vertical, the vertical slab, are uh, positioned relative to that uh, parent transform. The slab H is a rigid body. The slab vertical is also a rigid body, and it has a fixed joint component. And the joints have something called the connected body. This is what they're connected to. And so the vertical slab is connected to the horizontal slab. The brake force and brake torque are both infinity. And if I if I run this, this thing is going to fall, and it maintains this rigid connection. I can push it around. I can walk up. Whoops, I can't walk up over it. I can push it around, and but I've made this object. If I take and set this down to 100 and its brake torque to 100, I'm not sure what will happen here. When it hits the ground, this thing may or may not break apart. Yep, it did. So there's the brake torque. So we can make objects that we can blow up and break apart, but that will have some connection to each other through this fixed joint. Now, the next kind of joint, here's the walkthrough of what to do to make that. Now, the next kind of joint is the hinge joint. Don't save. So here's a hinge joint. And here I have my, my vertical slab is now sitting here in the world. I've got this object up here, the sphere. I'm not sure I'm using it or not, but which sphere is that sphere? I am using it. So here's the hinge joint component. It has a connected body, and so it's connected to this sphere. I assume it's that sphere, not the other sphere. One thing to note when you're working with these joints is that if you leave the connected body blank, if you leave it at none, if it were none, the connected body is considered to be the world. So the world, of course, has a coordinate system. It has an origin, 0, 0, 0. And so with connected body set to none or blank, we're connected to the world. This would work exactly the same way, but it's better to connect it to a physical object. Now, the hinge joint is a little more complicated in that it has this anchor. And it's best to go into wireframe here if we can see the object here. The anchor is set to minus 0.5 in the x direction. This is the x direction in this local coordinate system. And so the anchor goes from minus 0.5 all the way at the right-hand side of this thing to plus 0.5. No, the other way around, from minus 0.5 all the way to the left-hand side of this thing to plus 0.5 at the right. And you can see that little orange thing, that's the anchor's axis. And so if I move this over here, I can change the axis about which this hinge is going to rotate. I want this to act like a door, so I'm putting this all the way at one edge at minus 0.5, but I could put it in the center, in which case it would be a spinning turn style, or I could put it all the way at the plus 0.5, and it would be at the other edge. Now, the other thing to note is the axis. Let me move this in here a little bit so we can see it. The axis is what direction that thing is pointing. Now, I have it set to the 1 in the y direction, which means it's pointed up. It's rotating about the object's y-axis. If I set this to 1 in the x, notice now it's going to rotate about this axis. It's going to rotate about that skewed thing. If I set this to 0, now it's going to spin like a paddle wheel. Let me put that back the way I want it. Minus 0.5. The axis can be outside the object if you want it to be. Auto configure will just figure out things that it needs to know. You can manually configure it if you want to. So let's have a look at what this looks like. So there's my hinged object. I'm going to run through the door, and you notice that I push it out of the way, and the door continues on spinning about its axis. And as it rotates back around here, I can come and stand in the way here, and it'll hit me and stop, and I can push it and it spins the other way. Very cool. Now, so connected, the object it's attached to, by default the world, the anchor where the axis is relative to the object, and the axis about the vector about which it rotates. Now, the other thing that the hinge joint has is a spring. So let me go to the next scene here. I'm not going to save that. I'll leave it alone. And this one differs only in the fact that on my hinge joint, I now have turned on the use spring. With the spring, I have a strength of the spring. It's 10 units. They're kind of arbitrary. And a damper that is going to stop the bouncing around of the spring, and a target position, which is where the spring wants to set it to. So it wants to set it to a position of 0 degrees. So if I run through this one, now my door swings back shut because the spring wants to push it back to shutting it. The other thing that I've got in here is a limit. The other thing that I've turned on is a limit. I've got the use limits checked on, and my minimum angle is -90 and my maximum is 0. And what this means is that the door can't go back into +90 degrees. It can't swing around the other way. And that way I can have this door that I can walk through that closes behind me and that I can't get back through. So that's pretty cool in that you can make these one-way doors that you can't get through. Now I think there's also a motor. No, that's not what I want. Cancel. There's also a motor which will make the make it spin. My slab, I don't think I have an example of this, but if I turn off limits, turn off spring, and turn on motor, now I have a target velocity and a force. Strictly speaking, it's a torque, and the free spin, and this now will make my door spin around at 35 degrees per second. It's not, I can still push it, and it stops, and it has a certain force, so it takes a while for it to come back. And you can actually set limits on the motor so that it moves to a particular direction at a particular speed. Now, one more thing with the hinge joint. So save. Here what I've done is I've taken a bunch of different objects. I have the top beam, the middle beam, and the bottom beam. And the top beam, just so you can see it happen, has no connected body. So it's connected to the world. And you can see where its little axis is. And the middle one is hinged to the top, and the bottom one is hinged to the middle. And they're each connected here at these different spots. And if I let this play, what I get is a very nice chain that hangs down and behaves very physically like a chain of objects swaying back and forth. This is also pretty cool. So make 3 objects, top, middle, and bottom, position appropriately, add rigid bodies and hinge joints. Top is connected to the world, middle to the top, bottom to the middle, and it swings like a chain. I'm going to stop at this point, and I'm going to pause for stop recording, and I'll see you in class. I'll pick up next time with the hinge joint, the configurable joint, and the character joint. I'll stop now. Bye.